Hello everyone. Today in this video we'll learn some things about rational as well as irrational numbers. Let's start with what are rational numbers. Rational numbers, they are numbers which can be written in the form of p upon q. For example, suppose I have 3 upon 4. This is a rational number. Why? Here my p is equals to 3 and q is equals to 4. Let us take another example, 5. 5 is a rational number. Why is 5 is a rational number? Because 5 can be written as 5 upon 1. What is the value of p over here? 5. What is the value of q over here? 1. So 5 is a rational number. Let's take some more examples. Minus 2. Is minus 2 a rational number? Yes, minus 2 is a rational number because it can be written in the form of minus 2 upon 1. What is p over here? Minus 2. What is q over here? 1. Another example, 0. Is 0 a rational number? Yes, definitely 0 is a rational number. Why? Because it can also be written in the form of 0 upon 1. So, rational numbers are numbers which can be written as p upon q, where p and q, what are p and q? They are integers, and this q, your denominator, is not equals to 0. Okay? Now, let us study the decimal expansion of 1 by 3 and 5 by 6. So if I divide 1 by 3, let us divide it. So since 1 is less than 3, so point will come over here and 0 over here. Now 3 3s are 9. When I subtract it, what I get here? Again, remainder is 1. Then again 0 here. Again 3 3s are 9. Now again when I subtract it, remainder is 1. Again 0 here. Again 3 3s are 9. Now I subtracted. What is my remainder? 1. Again 0. Again 3 3s are 9. And when I subtract it, remainder is 1. That means your remainder is always 1. And it will never stop. Your remainder will never be 0. Okay. So what is the decimal expansion of 1 by 3? It is 0.33333 and so on. This 3 is never going to stop. It will continue. We write it as 0.3 bar. Bar over 3. Why? Because what is repeating? 3 is repeating. Okay. Now similarly, let us check it for 5 by 6. When I divide 5 by 6, again as 5 is less than 6, I'll put point over here and 0 over here. Now 6 8s are 48. When I subtract it, what I get? 2. Again I have to put 0 over here. 6 3s are 18. Now I subtract it. What am I getting? Again 2. Now again 6. I'll put 0 over here. And 6 3s are 18. When I subtract it, again remainder is 2. Remainder is 2. It is repeating. Remainder is never going to be 0. That means this decimal expansion is never going to stop. So what is the decimal expansion? 0.833333 and so on. It will continue. So how will you write it? 0.8 and now bar over 3. Okay, why just over 3, not over 8? Why? Because what is repeating? My 3 is repeating. Okay, so on the basis of this, when you see that for a rational number, when we have a rational number which is in the form of p upon q, where your denominator q is not equals to 0, we have two type of decimal expansion. When we see a rational number, we have two type of decimal expansion. First is terminating decimal expansion. Terminating means which will stop, where remainder will be 0. At some step, when you divide it, remainder is 0. For example, 1 by 4. When I divide 1 by 4, what is the answer? 0.25. Right? So, decimal expansion has stopped. That is called terminating decimal expansion. And just now we have seen 1 by 3. What was 1 by 3? 0.3 bar. Remainder was never 0. It was an endless pattern. 0.333333. It will continue. So such decimal expansion is called non-terminating. Non-terminating means it will not stop. It will continue but repeating. You will always see a pattern. right? So for rational numbers, whenever you see a rational number and whenever you find the decimal expansion, either it is terminating decimal expansion or it is non-terminating decimal expansion. Okay. Now, so we have done rational numbers. Now what are irrational numbers? Irrational. So irrational numbers are numbers which are not rational. Simple. Okay. So rational numbers were numbers which were fractions or which were in the form of p upon q. But this irrational numbers cannot be written in p upon q form. Okay. And the decimal expansion is non-terminating, non-repeating. Non-terminating and non-repeating. It will never stop, remainder will never be zero, and you will not be able to see any pattern. No pattern in the decimal expansion. For example, let us take 2.1423056789401 and so on. What is repeating? Can I tell what will come after 1? No. Right? So such numbers are irrational number when the decimal expansion is non-terminating also and non-repeating also. Okay? So irrational numbers are numbers which are not rational. The decimal expansion is non-terminating and non-repeating. Okay? Let's take some examples. So let's check whether rational or irrational. 0.75. Is this rational? Yes, it is rational. Why? I can always write it as 75 upon 100. So it is rational. What kind of decimal expansion? Terminating. The expansion is stopped. 0.75. Nothing after that. So it is terminating. Number is rational number. 0.232322323. How it is written? 0.23 bar. What is repeating? 23 is repeating. Right? So the number is rational. What kind of decimal expansion? Non-terminating repeating. What kind of decimal expansion? Non-terminating means it will not stop and but repeating. Okay. Root 2. Root 2 is irrational number. Right. Pi. Pi is also irrational number. Minus 7 by 2. Minus 7 by 2. That is a rational number. Okay. So question. You have to tell which is rational. Square root 3. Square root 3 is not rational. We know. Now 0.101001000 and so on. So is there something which is continuously repeating? 10, 10, 10. No, no, no. Nothing is repeating. So this is also irrational number. 22 by 7. Let's check 22 by 7. Is this rational? Yes, this is rational. Why? What is my P? 22. What is my Q? 7. So this is a rational number now. So answer is C. Pi is again an irrational number. Okay. So what is the summary? So in summary, what are rational number? Rational numbers, they have two type of decimal expansion. First is terminating. Second is non-terminating repeating. Okay. Non-terminating repeating. And when the number is irrational, it's what is its decimal expansion? Non-terminating, non-repeating, and there is no fraction. No fraction form is there. Right? Here are some examples. Root 2, root 3, root 5, pi, e, all they are what? All they are irrational numbers. Okay? Now, this is your homework. You have to tell which number is irrational and rational. Root of 49 and this 1 by 7, root 11. Okay? And that's it. So, I hope you have learned what are rational as well as irrational numbers. And kindly do practice it because practice makes things perfect. Thank you.